We're going to look at Huawei tonight. We're going to look at a technology called human bond communication. And in my view, this is one of the major issues as it relates to the future telecommunication space. And that relates to how humans are going to communicate moving forward in time. And so this whole talk about 5G and this fight with Huawei and all of that, there's a lot going on. So we're going to do a quick review on Huawei and at least what's going on in the public space. This was February 28, 2020. A bill seeking to ban Huawei from U.S. wireless market heads to the president's desk. And really what this talks about is that the Senate basically says that they unanimously passed a bill that aims to restrict and or interrogate foreign technology companies as it relates to our telecommunication infrastructure. And not really going to read what this says, but what I want to highlight to you is it's beyond Huawei. It's also ZTE. And ZTE is everywhere. ZTE has been installed for the last 30 years in just about every facet of our telecommunications infrastructure. Thank you, Awkward Mama. We're on episode 67. And same drill. Twitter, human internet 1, Parlor, human internet. It's Gab, human_internet. And the website that I'm building out is humaninternet.org, which we'll look at a little bit today. So we are on episode 67, and these notes are rather extensive. So what I want to basically, outline really is where we're at politically and publicly with this whole 5G business. And it's beyond Huawei. It's more than that. And to that point, right? So we've got April 4th, 2020, executive order establishing the Committee for the Assessment of Foreign Participation in the United States Telecommunications Services Sector. And this was an executive order by President Trump. And what it really discusses is the formation of a committee, bureaucracy, basically, that has many different federal organizations cooperatively looking at national security related issues when it comes to telecommunications infrastructure. And it talks about setting timelines for evaluation and issuances of licensure. And when we have existing infrastructure in place, there's discussion here that states requirements and timelines for evaluating existing infrastructure and then making plans to go forward as it relates to correcting our existing infrastructure. And I say that because you've got Chinese companies like ZTE that, they're everywhere. They're in every cell site. I've seen them with my own eyes. I've seen their systems with my own eyes, and they're not the only ones. You have European companies, you've got Canadian companies, you've got Japanese companies, Chinese companies. Notice I didn't say American companies in our telecommunications infrastructure. So we are going to focus on the importance of national security and the importance of 5G as it relates to the future of our economy and our viability as a country. And this goes for any country for that matter, because Huawei is global. And so there really is a choice at this point, whether or not countries are going to accept a Chinese model, Chinese infrastructure, or some other infrastructure. And you're going to see why here as we move forward. So this was back in 2019, Huawei and China facing U.S. charges and have few ways to retaliate. And this has to do with Meng Wanzhou, chief financial officer at the Chinese technology giant Huawei. She was arrested in Canada. This was January 29, 2019. And it says here 2 months ago that she was arrested. She was arrested late 2018. Chinese officials have denounced the move, declaring it wrongful and arbitrary. And they talk about inappropriate relations with Iran after global sanctions were placed on Iran. So it's, in my view, it's far beyond Iran. What this is this is a puff piece that provides public disclosure to the world in the public space outside of the intelligence apparatuses that cooperate behind the scenes to get into the books of Huawei. And when you're talking about arresting the daughter of the head of the company, Meng, daughter of Huawei's founder, chief executive, Ren Zhengfei, right, who's part of the CCP and tied into the military, Chinese military, it's far beyond just their dealings with one country. That to me does not justify looking for extradition, placing this woman on house arrest, seizing her assets, and poking around in all of their financials. This is a chief financial officer. And so everybody knows, right? When you want to look at something, follow the money. So there's a lot more going on than just what's being disclosed with Iran. Talks about a trade war, and I highlight that only because when we think about 5G and we think about interconnectedness, telecommunications, Internet of Things, it has everything to do with the economy. We're moving into a digital cyber economy. Automation is going to replace a lot of labor-based jobs that humans used to do. And so the economy is going to shift into a more automated environment, and that's going to force people to have to retool themselves, re-educate themselves, upgrade their skills, so to speak, to adapt to this newer economy. And if it's done properly, there's really an opportunity, I think, to generate a bunch of synergy where the quality of life has a potential to improve. Unfortunately, looking at the trend as it stands today, that's not happening. Everybody's not working, and they're getting subsidized by their governments, and 5G and automation is still moving forward. The fourth industrial revolution is still moving forward. And there's a window here where there will be opportunity to bring the workforce, the human workforce, back online and retool them in place as automation sort of displaces human labor. What that looks like, I think, is going to be independent. Each country is going to have their own plans or their own model for how that's going to look. And in some countries, unfortunately, I think that's going to be a very, very difficult, negative experience for the general population. I personally don't want to see the United States go that way. But we're still, in the United States anyway, we're still henpecking each other over a mask. And we're not looking at these larger issues. So what I want to highlight here is that they replaced Meng with this lady, Joy Tan, and she didn't take over all of her functions. But the reason I highlight Joy Tan is that it says here, this was 2019, she's currently the head of global communications. Well, she now is the primary liaison with America as it relates to Huawei's business in America. And here's why she stuck out to me. So Joy Tan, this is 2020 South by West. That was canceled, I believe, or modified. She was going to be there. Senior VP Public Affairs, Huawei. Senior VP of Public Affairs, Ms. Tan is responsible for setting and executing public relations and government relations strategies for Huawei USA. From 2014 to 2019, Ms. Tan served as president of global media and communications for Huawei, setting and executing media and communication strategy for the entire company. So from 2014 to 2019, she was setting the tempo for the media and communication strategy for the entire company of Huawei. She was instrumental in promoting Huawei's thought leadership, corporate values, key products and solutions, making Huawei one of the top 100 brands in the world. The scope of her work: strategic communications planning for all three business groups, managing company-wide engagement with international and Chinese media, guiding advertising, social media, branding campaigns aimed at building Huawei's global profile, representing the company at major industry events and conferences such as the World Economic Forum and the United Nations Multi-Stakeholder Forum on Science, Technology, and Innovation. Now, this is important because we are going to look at one of their corporate documents. And yeah, McBurger, just wait, buddy. Just wait. Prior to this role, Ms. Tan was responsible for corporate branding, where she led the initiative to transform Huawei into a global brand. She also managed Huawei's integrated marketing and communications in the United States. Before joining Huawei, Ms. Tan worked at Verizon. That's an American company that was spun off from AT&T and or Pacific Telesis, the Bell companies. And then Verizon became its own behemoth, and in my view, is controlled market opposition in order to prevent the perception of a monopolistic telecommunications industry in the United States. So she worked at Verizon. So did Bill Barr. Bill Barr was a senior lawyer for Verizon for quite some time, as a matter of fact. I wonder if they know each other. So while she was at Verizon, she was responsible for consumer strategy and digital marketing. And she worked at Texas University, or TXU Energy, where she led customer acquisition efforts in the newly deregulated energy markets. Ms. Tan studied biology at Tsinghua University in Beijing and holds a master's degree in neuroscience. And I want you to remember this. She holds a master's degree in neuroscience from the University of Texas Southwestern Medical Center and was a PhD candidate. She holds an MBA in marketing from the University of Texas at Dallas. So this is a lady who runs major components of Huawei, which is a primary adversary as it relates to the United States. And when you look at cyber as a battle space, Huawei is a primary adversary in a wartime environment. And here she is, trained and bred in the United States, in particular in Texas, with backgrounds in neuroscience and marketing, and now is the primary liaison to the federal government for Huawei. So 5G. High level. We're not going to dig too deep into this because we're going to talk about 5G for many shows. But I want to show you a little bit about what 5G looks like before we really get into the meat and potatoes of tonight's discussion. McBurger, stay tuned. Huawei, 5G at a high level. Cloud, 5G architecture, everything in cloud, everything is software. What this means is that the antennas all need to be able to function the same way. You will have a universal antenna or antennas, just like a universal remote works on all televisions. The universal antennas will work with all cloud type configurations. And so you have a standardization of cloud infrastructure and you have a standardization of hardware infrastructure, meaning all of these wireless antennas that will be the 5G construct, the 5G apparatus. So through persistent effort and determination, telecom operators are implementing a digital transformation to create a better digital world, to provide enterprises and individuals with real-time, on-demand, all online, DIY, social roads experience requires an end-to-end coordinated architecture featuring agile, automatic, and intelligent operation during each phase. So automated networks run and managed by AI. Software-based, software-defined networks, and what they call network function virtualization, where everything that used to be done on a computer as hardware is now done virtually as software. And the hardware is just this universal plug and play thing that functions as an end device to provide the necessary hardware to interface with the environment, including humans. The all-cloud strategy is an illuminated exploration into hardware resource pools, distributed software architecture, distributed software architecture, and automatic deployment. The reason distributed software architecture is critical is because when we look at things like the executive order and what they should be looking at, in my view, is pieces of Huawei are distributed already in the rural areas. They're already out in the rural areas. So when we look at distributed software architecture, if we have Chinese telecom infrastructure in a country's telecom architecture, this distributed software architecture idea provides opportunity for even just a piece of Chinese telecom equipment or components, many components. Let's say they have a couple towns in a region, to be able to reach out across the local network. So just because Huawei isn't everywhere, and I'm using Huawei because we're focusing on Huawei, but this is true for any country's infrastructure, any country's architecture, any country's hardware that's used in the internet. If that hardware is smart hardware, where it's able to receive software, manage software, run software, etc., it now provides an access point into the country's architecture, into the country's telecommunications infrastructure. And you think to yourself, well, how can that be? If it's just a section in the internet and it's not touching the outside, it's not touching the edges, how can that be? Well, it's really this simple. You can hop. And there are technologies that allow you to hop around the network until you find what you're looking for. And with advanced encryption, particularly quantum, you can go anywhere you want. And if that doesn't resonate with you, we are putting satellites up to the tune of like 100,000 of them, 20,000 of them. I can show you articles that say 20,000, but that was years ago. And more countries are getting involved, setting up these satellite mesh networks that are going to orbit the Earth. And so this whole cybersecurity Space Force thing has a lot to do with regulating the internet in space. Because now when you have satellite constellations that are crossing over the continent, let's say North America, and you have, for example, Huawei infrastructure that have radio antennas, you are now able to communicate potentially internationally, circumventing all of the natural land borders and all of the firewalls that would be associated. So this is the real underpinnings, in my view, of this executive order. What does cybersecurity look like when you have satellite mesh networks that can beam down and communicate with an isolated area that ultimately interconnects into a country's entire internet infrastructure on a real-time, ongoing basis? So we're going to get more into the architecture of 5G, but I'm really just trying to lay out the foundation of how software manages the networks of today. And it just takes a little bit of hardware and you're in somebody's country. And this is the risk. These are the decisions that every country has to make as it relates to their internet upgrades, their infrastructure of tomorrow. And I say that because the internet of tomorrow will be with humans integrated into it. McBurger, are you listening? So it doesn't stop. Doesn't stop Huawei with their open radio antennas and all of that, because you have organizations like this, ORAN. The ORAN Alliance integrates major players, AT&T, China Mobile, T-Mobile, Orange, which is a major European company. T-Mobile is also majorly deployed in Europe. China again, Airtel, Dish, Sprint, Verizon. It goes on and on and on and on. And you have lots of companies that deal with the stuff you don't see, right? So what I mean by the stuff you don't see, the research and development, the hardware components that are necessary to make the internet talk behind the scenes, office to office, place to place, tower to tower. The brands that aren't plastered on your cell phone or your router. The brands that are in the industry catalogs that 99% of people never see. That's who's also participating in this ORAN organization. So, Expo, seen them. Fujitsu, seen them. I've seen Ericsson. I already told you I've seen ZTE, Infineon, IBM, Intel. So now you're talking about chips that are in just about everything with Intel. And Infineon built Google Pixel's new radar hardware for their Pixel phone. We'll get into radar again when we start looking at beamforming and wireless techniques. Keysight, familiar with them. Juniper, familiar with them. Microsoft, NEC, Nokia. Nokia owns Bell Labs. Bell Labs has been passed around like a whore over the last 10 or 15 years. And so major companies like Alcatel and Lucent, who have a giant Asian presence, particularly in China, they've had access to Nokia Bell Lab technologies for well over a decade. And folks, that's the lab that basically took over R&D for government, for everything, for telecommunications. And that ranges from wire, line, copper, fiber, wireless, and all other interrelated disciplines. Nokia or Bell Labs is a major R&D organization, and it no longer really functions inside the United States anymore. AT&T has spun out their own R&D and distributed the rest of it to the rest of the world. So this has to do with intellectual property distribution that may or may not have been a good idea, considering the United States basically made that laboratory. NVIDIA, graphics people, gamers. So the point of showing you this is, here's ZTE right here, is that major players that are responsible for building and or supporting the construction and maintenance of wireless and internet hardware and software are all converging into these common organizations to develop uniform, universal connection points that will allow everybody, every user, every provider to talk on the internet seamlessly, so that anyone or anything can jump from network to network to network to network seamlessly. And at some point, we'll dig more into ORAN because they have white papers and all kinds of stuff here that are really, really good. So basically, it says right here, networks are becoming increasingly complex with the advent of 5G, densification, richer, more demanding applications. To tame this complexity, we cannot use traditional human-intensive means of deploying, optimizing, and operating a network. Instead, networks must be self-driving. They should be able to leverage new learning-based technologies, AI, machine learning, to understand how to run these radio antennas, to automate operational network functions and reduce OpEx, operational expense, telecommunication operating expenses. So the ORAN Alliance will strive to leverage emerging deep learning techniques to embed intelligence in every layer of the RAN architecture, radio antenna network architecture. Embedded intelligence applied at both component and network levels enable dynamic local radio resource allocation and optimizes network-wide efficiency in combination with standardized southbound interfaces. AI optimized closed loop automation is achievable and will enable a new era for network operations. This is huge. Huge. So back to Huawei. 2017, Huawei European Innovation Day in 2017, London, UK. And here is this lady, Joy Tan. This was before she was the liaison to the United States government. She was responsible for the global marketing and other functions for Huawei. So 2017, corporate trade show, if you will, and Huawei's funding it. And you've got all kinds of people, all kinds of fields of expertise that participated. And we are going to look at this guy today. Ramji Prasad, Knight of the Order of Dannenberg, Fellow of the IEEE, IET, IETE, and WWRF. Why do you ask? What's so special about this guy? Well, I'll show you. This is his presentation from this European Innovation Day 2017 in London. How new technologies and the new industry revolution boost the economy through smart connectivity. Knight of the Order of Dannenberg, Distinguished Award by the Queen of Denmark. For those of you that like to look into people, look her up. I bet that's an interesting read. Okay, European Innovation Day 2017. So I want to draw your attention here to this. He's written many papers, many books, holds patents. Wireless World in 2050 and Beyond. This is a textbook. He is a professor, and his students end up being leaders in the telecommunication industries that they go ultimately work within. This guy is very intelligent and a major player. This next piece, human bond communication. And this is really the centerpiece of tonight's discussion. The holy grail of holistic communication and immersive experience. Human bond communication. What is that? More books, papers, etc. 5G. So let's continue. FT4BI is a nomenclature or label for what he's basically marketing. And human bond communication, in a nutshell, we'll look at this diagram again in other documents, but what this is this network, this over-the-top service of 5G is able to image something, person, place, thing, quantify it as it relates to how a human would interpret it with all five senses: see, touch, taste, hear, smell, transmit those in a digital form, and then insert those into the human so that you get immersive, virtual, or augmented reality based on what level of sense transposition you've signed up for. This is a commercial application, so you better believe that this is already well distributed. What do I mean by that? Huawei partnering with FT4BI. This is an ongoing research endeavor. 5G, future wireless communication era, excuse me. So 5G 2020 into the future, 2050 and beyond. And so what this looks like is setting an infrastructure that will be able to support this human bond communication architecture that will then be able to do things like transmit emotion over the internet. And the knowledge home, which we'll look at, which is a fully immersive, interactive experience whereby the home is connected to the human, humans are connected to humans, and it's all done digitally. And you could have complete and total sensorial experiences with another human, be it in your home or in someone else's home or at distance, because of the network architecture that is going to be constructed for this human bond communication over the top service. Human bond communication is a novel personal network concept that has the capability to express and transform all 5 human senses into the information domain so that it can be transmitted and received like any other existing data form that are being exchanged today. So what does that mean? All 5 senses can be transmitted and received over the internet, just like the 2 senses that you're using right now, your eyes and your ears, to understand what's going on. Your computer, your phone, your TV, whatever it is that you're looking at. Your eyes and your ears, that's 2. You're talking about transmitting all 5 and inserting that into you. Diagram of emotions, aggressiveness, contempt, remorse, disapproval, awe, submission, love. Now, how useful would this be trying to run a campaign? How useful would this be if your loved one was on another planet? What if they're deployed overseas here on Earth? What would intimacy look like over the internet? What would learning look like? Positive reinforcement, negative reinforcement look like virtually, considering we're all cowering in fear over something that has a 99.7% stay alive rate? The virtual environment is being thrust upon us on purpose, and it is many, many fold, one of which is to isolate people. And once that has occurred, bring online these types of technologies to replace what it is that makes us human. Emotions. Here's the knowledge home. And here they have broken out vision, or seeing, smelling, touch, hearing, and taste. Vision, olfactory, tactile, auditory, and gustatory, which is taste. Notice that they've got them all pointed to the home. Home is connected, and you have wireless connections. 1s and 0s, which implies the digitization of these information domains that ultimately interact with the human. And this is what smart connectivity would look like. These technologies tied into the cloud that are run and managed through the telecommunications infrastructure, that have government and municipal first responder services all integrated, as well as friends, relatives, and businesses, everything connected, smart city, smart home, everybody connected on the internet, up to and including your thoughts. Being able to transmit emotion and sensation. I'm talking sensation. What would it feel like to have a virtual conversation with somebody and have them want to stroke your arm or touch your face or give you a kiss? Can you imagine for a moment how that would translate to interfacing with your nervous system and your brain to give you the sensation of what that would feel like, as if the person was actually doing it to you in real life? What do they smell like? What does their mouth taste like? So the networks are standardized at this point, folks, all the way down to nanoscale. And we will look at that in some detail. Nanoscale, near field communications, personal area networks, body area networks. Notice this guy's all lit up, right? Metropolitan area networks, wide area networks. This is how the internet works. Stuff has been around for a long, long time. Near Earth and interplanetary communications. And here you have fiber optics, copper, coax. You have wireless networks that are terrestrial, and you have satellite. And what they've done here is they've shown you in an infographic how all of these things integrate and interrelate, and they are all being standardized. And that has really been the basis for this entire show, as long as you have been listening. So human bond communication, what's that all about? Future wireless systems for human bond communication. In the near future, the capability of the human being to communicate sensation is going to be enhanced by incorporating the 5 sensory features in the messages, meaning what you transmit over the internet, and allowing more expressive and holistic sensory information exchange through communication techniques. That is, being able to exchange your 5 senses with somebody else over the internet. The human bond communication is currently a vision. This was in 2016. So just bear that in mind, because the commercial applications are not yet deployed in 2016. 5G wasn't really even on the general populace's radar. It was being talked about in the telecommunications industry, but not in the general public. And so they're rolling this out piece by piece by piece by piece. So it says it's not currently a vision, but it's expected to become true. The objective of this paper is to give an overview of the potentiality and the main challenges for the adoption of human bond communication in the existing and future wireless systems, starting from the human bond communication features. A flexible architecture that could be considered for the development of these systems is described, highlighting how wireless systems could eventually boost the human bond communication adoption in different scenarios. The wireless option is absolutely required for this technology to function, folks. Security and privacy issues are presented, focusing on the requirements and the new threats, identification, and propose some possible solutions. Finally, some potential application contexts are analyzed, and the open key issues for human bond communication implementation is addressed. One of the main goals of the future pervasive communication ecosystem is the improvement of the quality of our lives by increasing comfort and the enrichment of the interactions and conditions of our everyday activities. In the near future, this general objective is likely to encompass the capability of human beings to communicate sensations by incorporating the 5 sensory features in a message and allowing more expressive and holistic sensory information exchange through the internet. However, even if it has been decades since communication technology has enabled the acquisition and transmission of oral and optical information, right? So eyes and ears, multimedia, video, YouTube. On the contrary, the possibility to integrate the olfactory, gustatory, and tactile sensory features in the communications network is still far from reality. So being able to incorporate the sense of smell, the sense of taste, and the sense of touch. And I will submit to you, I will show you how that is incorrect, how we are already here. The infrastructure is already here as time goes on, even tonight. Being able to integrate the sense of smell, taste, and touch. Nonetheless, human bond communication is a recently defined concept that incorporates smell, taste, and touch sensations, pursuing a more human-centric communication for future networks. Paper is organized in these ways, and it summarizes human bond communications, describes the flexible architecture that needs to be adopted, discusses how upcoming future wireless systems, 5G, wireless body area networks, how they could eventually boost the adoption of human bond communication. They detail security and privacy issues and address open points for the development of human bond communication. So, human bond communication has been recently defined as a holistic approach to describe and transmit the features of a subject in the way that humans perceive it. Therefore, all 5 senses are to be exploited in order to convey the physical subject into the information domain and allow its comprehension by 2 mutually agreed users of human bond communication. So imagine allowing the internet to sense you and to convey your intent to somebody else that's far away. See, touch, taste, hear, and smell. How do we do that? Well, you have to be able to map the brain. You have to be able to map the nervous system. You have to be able to archive what it is that's going on in someone's brain when they interpret a tap on the shoulder versus a hug versus anything else. And once those are archived, then you just send those signals to the brain and the nervous system of the individual when the other person who you're communicating with wants to have you experience that. And there are patents that show that that is absolutely possible. So I'll read this paragraph and a little bit more, and we'll stop and I'll show you what I'm talking about, because that to some people probably is just like, well, that's impossible. I'm not off the rails, folks. I'll show you. The comprehension of the information opens the way to the perception of the brain via neurotic pulses. Neurotic. Now, don't get confused. Neurotic doesn't necessarily mean crazy. Neurotic just means neuronal. Nervous system, neurons, which are what your brain and your nervous system are made of. The pulses, the right sequence of pulses in order to get the interpretation of one or all of the five senses to create a virtual reality or an augmented environment reality. That is what this technology is trying to achieve. As a consequence, the brain captures the sensed information from all of the sense organs simultaneously and creates a perceptual image that has not only the visual property, but other attributes like smell and taste. This complete description is stored in the brain to be accessed for future use. So, another document, human bond communication. And I want to show you this. Realization of a physical entity. Smell, sensed by the olfactory receptors, neurons. Sound, sensed by the auditory nerve, vestibular nerve. Vision, sensed by the optic nerve. Taste, sensed by the glossopharyngeal nerve. And touch, sensed by the somasensory neurons, and there are many of those. There are pressure, temperature, mechanical, there's electrical, there's all kinds. And I can show you exactly what I'm talking about. So why don't we digress here for a second? As it relates to smell, we're going to read some of these patents here real quick. This is BrainQ Technologies. Q just stands for resonance. If you look up what Q is, it is a definition of how well something resonates. It's an energy efficiency as it relates to the resonance of something. And what they're talking about is finding the unique resonance for regions or circuits in your brain or regions or circuits in your nervous system. That is what this company does. It's funded by Google. Therapeutic electromagnetic field uses a coil, antenna, or any other conductor, right, to apply time-varying electric field or magnetic field, such as to the nervous system of an individual. And it's done with very, very, very minimal amount of energy. They measure it in Gauss, and it's ridiculously low. It's well within what's currently regulated within the regulations for the FCC. So it talks about frequency of an electromagnetic field may be selected for a particular treatment appropriate to general region or functionality of the brain or of the nervous system, the motor systems, the memory systems, or other general functionality. Frequency may be appropriate to a particular region or functionality of the brain or the nervous system, movement of a particular limb or muscle, particular type of cognitive ability, or other particular function. A plurality of signals of different frequencies may be concurrently applied. So now we're getting into maybe more than one sensation at a time. In this manner, more than one region or functionality may be treated concurrently. This is a medical patent to rehabilitate somebody who has cognitive decline, paralysis, basically something that damages or basically some damage or malfunction to the brain of the nervous system. That's what this company is researching. So here are the power strengths: 50 Gauss, 10 Gauss, 5 Gauss, 0.5 Gauss. You can look this up. We went over it before. And on the website, humaninternet.org, under the BrainQ tab, you will find this conversion here. And we're talking about just fractions of a Tesla in order to get these kinds of effects. So to smell, right? Let's find smell. Smell. So it says here, without being bounded by this theory, the characteristic frequencies of electrical impulses traveling in the brain and through neural networks and chemical pulses across synapses at a predetermined wave frequency, the present invention for the first time provides a means of resonating information signals and frequencies at which these information brainwaves move throughout. Considering the example of a subject who has a stroke and has subsequently been noted as having lost a sense of smell, when electromagnetic waves, remember the discussion, right? 5G. And we're going to get into the nuances of 5G, but this is important to understand that electromagnetic waves of the correct frequency can be transmitted to the brain. The olfactory region of the brain will resonate, as well as its surrounding regions, and cells from the surrounding regions will migrate to the olfactory region of the brain, thus at least partially repairing the deficit. So what does this mean? From a medical perspective, they can correct damage or malfunction. From a practical application perspective, if they can do that, then they can potentially resonate these circuits and induce smells based on the right neural impulses. And if those are mapped and cataloged in a database in the cloud, like Amazon's biometric cloud for the CIA or the DHS or any other Border Patrol agency, their biometric databases, this kind of stuff would be stored. And if you don't think that makes sense, I'll show you this. 1974, an apparatus and a method for remotely monitoring and altering brain waves. So you can send electromagnetic waves into the brain, and you can continuously monitor things like seizures, sleepiness, dreaming, bodily functions such as pulse rate, heartbeat, regularity, and others can also be monitored. You can also monitor hallucinations, which means artificially induced thoughts or visions can be monitored. And that's that closed loop system kind of thing, which they talk about here. Medical diagnosis of patients remotely from remote stations. This was back in the 70s, folks. A profile of the entire brainwave emission pattern may be monitored, or select areas of the brain may be observed in a single measurement simply by altering the scan angle and the direction of the antennas. Now, when we start looking at 5G and beamforming and MU-MIMO, multi-user MIMO, you will see that altering the scan angle is basically how the 5G system works. Narrow beams that are steered left, right, up, and down in order to provide the best service on a case-by-case basis, altering the scan angle. There is no physical contact necessary. The transmission to the brain to alter, I'll restate this, the computer can also determine a compensating waveform, an electromagnetic waveform, for transmission to the brain to alter the natural brain waves in a desired fashion. The closed loop compensating system permits instantaneous and continuous modification of brainwave response patterns. So we're talking about being able to transmit all five senses over the internet and inducing sensations into the brain and the nervous system of another individual for communication purposes. And in the 70s, they had patents that allowed continuous manipulation of brainwaves in a closed loop monitoring fashion. Electromagnetic signals of different frequencies are simultaneously transmitted to the brain. The signals interfere with one another to yield a waveform which is modulated by the subject's brainwaves. That's how it can be read. The waveform is then displayed for visual viewing and routed to a computer for further processing and analysis, which means they can catalog what's going on in your head. It can be used to produce a compensating signal, which is transmitted back to the brain to effect a desired change. So here's another one: communication system including brainwave analysis and or user brain activity. Use of brain activity, excuse me. So this one literally, this was back in 98 and it was published in 2000. A method for enabling human beings to communicate by way of their monitored brain activity. This is all no contact. We'll get to the contact pieces in a minute. Monitored and transmitted to a remote location, example by satellite. Brain activity being monitored and transmitted to a remote location. Satellite. It's compared, the brain activity is compared with pre-recorded, normalized brain activity curves or waveforms or patterns, right? So a database, they're compared. Then the computer at the remote location determines the individual was attempting to communicate the word, phrase, or thought corresponding to the matched, normalized, stored signal. A system capable of identifying particular nodes in an individual brain, the firings of which affect characteristics such as appetite, hunger, thirst, communication skills. Which nodes are used or utilized to communicate certain words, such as yes or no, or phrases such as I don't know or I'm not sure. Nodes that are associated with thought processes, depression, and the like. And so this was 20 years ago. And now we're talking about being able to understand the complexity of the brain to quantify, transmit, and receive using these cloud-based infrastructure, architecture, these cloud-based databases to transmit all 5 senses, not just thoughts, but all 5 senses. It says here that components may be energized to remotely cause particular identified brain nodes to be fired to cause a predetermined feeling or reaction to create things such as a lack of hunger or a lack of depression or a lack of thirst or a lack of aggression or a lack of Alzheimer's disease or the like. This patent discusses being able to use standard cell phone, LTE cell phone frequencies and current Wi-Fi frequencies, 2.4 and 5.0 gigahertz, to be able to map the microwave activity of the brain, or map the activity of the brain using microwaves, excuse me. Diagnosis of things like functional and emotional states of the brain, depression, aggression, emotional instability, mental disorders, mental diseases, military, medical, social, clinical, social, and labor applications. This is a Russian patent. For neurological and neurosurgical practice, for military medicine and disaster medicine. There's quite a lot of practical applications of this invention, being able to utilize electromagnetic waves in commonly deployed everything. Cell phones, Wi-Fi, cell towers, you name it, commonly deployed, right? For both peaceful and military purposes. And all of them can be created in the near future using methods of the present invention. And this website goes on for being able to modulate the brain to be able to do things like make you go to sleep instantly, and on and on and on. But let's get back to human bond communication, because we haven't really got to the wearable piece yet. So the comprehension of the information opens the way to the perception of brainwaves via neurons, neuronic pulses. As a consequence, the brain captures the sensed information from all of the sense organs simultaneously, creates a perceptual image that has not only the visual property, but other attributes like smell and taste. This complete description is stored in the brain to be accessed for future use. These are the biometric databases, folks. It's beyond your voice print. It's beyond your fingerprint and your face print. It's everything. It's every sensation. If they can measure it and catalog it, it's being measured and cataloged. And the infrastructure lies in the hands of big telecom and big tech. Those two work hand in hand. Facebook, Twitter, Google, Microsoft, Amazon, all of them. And then you've got your telecommunications providers, because they are the ones that live here. All of these folks are building the infrastructure by which these components, these sensations, your privacy, down to whether or not your nose itches, or if you have to use the restroom, or if you're having impure thoughts. This is the architecture piece. The software piece lies with big tech and all those apps on your phone. It takes two to tango, as they say. To achieve successful transmission of the human bond information via communication mediums, we must have a system that can sample and interpret the physical subject in the 5 sense domains, transform it into a data set, add encryption and other security add-ons, compress code, modulate the data by highly efficient systems, transmit that data through compatible medium like the internet, and retrieve the information at the receiving side. They talk about senducers, sense transducers, that perform sensory transduction of stimuli to electric signals, human bond sensorium, which is a unique over-the-top network architecture, and transmitting that information to human perceivable transposers that transpose the information. So that is the receive side. So you have senducers that collect the information, you have the network that transmits that information in digital form, and then you have the transposer that puts it into the nervous system of the human. What does that look like? I'll show you. So we can look at something we discussed on the last show or the show before. And what I'm talking about is this. Methods and systems for determination of physiological conditions and emotional states of a living organism. This is an Israeli-based invention. They hold patents in the United States. Predetermined modulated electromagnetic waves in the millimeter and submillimeter wavelengths, which is 5G range, for therapeutic treatment. Modulated information signals can be applied to the skin of a living organism. The signal can include information for modifying the organism's condition, such as their physiological condition and emotional state. What does that mean? That means that they can interact with your emotional systems, right? We had the Huawei document that discussed being able to transmit emotion over the internet, right? Feeling identification and transmission, one of the services that they're going to want to provide. That's just emotion, folks. What about the other senses, like the sense of touch? This talks about a medical application where information of a healthy organism is applied to an ill organism, and the healthy organism information can be conveyed to the spinal cord and the brain to regulate the condition and the functioning of the organism. And again, this is no contact. This is without modification, without alteration. This is no nanotechnology, no genetic modification, nothing that you wear like a headphone or a watch, or have a cell phone near you. This is literally just raw electromagnetic waves modulated so that they resonate with your brain and your nervous system to induce some type of a change. And the question is, how far will you let your mind wander as to how developed this technology is? Biometrics, they talk about. So they talk about here, some of the neurally connected structures distributed in the skin of a living organism may provide electromagnetically active functionality. This enables communication with the living organism using electromagnetic radiation. The term communication stands for either one or both of the following effects: radiation detection, the reception of electromagnetic waves emanated from the skin. Well, that sounds real similar to being able to extract these senses, isn't it? Doesn't it? What's emanating from your body. And radiation or stimulation / excitation of the skin, transmission of electromagnetic radiation to the skin. Well, that would be, once these are extracted, they're sent over the internet and they're modulated in a certain way in order to give another individual whatever these sensations are that are intended to be delivered through the skin, in this case, in this patent, just the skin, in order to interface with the brain and the nervous system and the spinal cord to do things like change your emotion or change your physiologic state. So, the known capacitance and resistance of the human skin raises the possibility of considering the human skin as a spatial distribution of circuits composed of resistors, capacitors, and inductors, known as RCL circuits. An example of neurally connected and electromagnetically interacting structures distributed in the skin include, but not limited to, sweat glands. There are more. It would be advantageous to employ an individual pattern of sweat glands distribution in each person, right? What this means is that each person has their own unique pattern of sweat glands, which can allow to utilize unique bioelectric signatures associated with bioelectric activity of sweat glands for human identification, diagnostic, and treatment. So you have a fingerprint that is the unique distribution of sweat glands that can be read and understood wirelessly with electromagnetic energy in the 5G frequency bands. Your sweat glands are unique to anyone else's, which means you don't even need a phone to be tracked. You don't need a phone to be interfaced with, because that is your encryption key. That is your biometric identifier. And 5G will be everywhere. So from an intelligence perspective, he who has the infrastructure, the hardware, ultimately has advantage as it relates to intelligence and influence, most importantly, and influence over a society. What do you think China is going to do with this kind of technology, folks? So it talks about being able to read and or induce physiologic changes, right? Example of physiologic conditions include, but are not limited to, conditions caused by exercise, environmental conditions such as temperature and humidity, illness, puberty, menopause, menstruation, metabolism, etc. Examples of emotional states that can be read or induced, but are not limited to, stress, anxiety, fear, anger, nervousness, embarrassment, panic, general neurologic disorders. They have an active detection. The electromagnetic waves emanated from the skin, right? It can be basically what they say here is that they can modulate the body with high frequency electromagnetic waves and then read the change of the modulated waves that have been transmitted to the skin. They could read that change as a form of active detection. Right? So applying the predetermined modulated electromagnetic waves to the skin. And when we start looking at 5G and beamforming and how narrow these things can be, you will see exactly what I'm referring to. And we will come back and revisit these things as a reminder. But I encourage you to watch this. Stay tuned. And if you can't, watch the rerun, because this is going to stack one layer on top of another on top of another. So it says here, radiation pattern associated with the sweat glands are unique to an individual, and that a human body has 2 to 4 million sweat glands. We're just talking about interfacing with sweat glands, not organs, not brain circuits, not anything else. This is just one method. So there is another piece I want to share with you, because we need to talk about the sensation. How would they be able to give you a twitch or an itch or a sensation of warmth onto your skin, right? And here it is. Skin is the body's largest organ. It accounts for 12 to 16% of body weight. The skin is also a vital tactile sensory organ, and its mechanical characteristics greatly affect the nature of neural patterns which occur where it makes contact with an object. For example, neuromechanical receptors, mechanoceptors, detect superficial and deep pressure, such as brushing, vibration, flutter, and indentation. Temperature sensors, thermoreceptors, and pain receptors are detected by different sets of electric receptors. These skin sensors, along with muscle and joint position awareness, or proprioception, proprioceptors make up the mosaic of the somatic senses. Somatic senses. They make up the somatic senses: touch, tactile, somatic senses, somasensory neurons. So we just spent a great deal of time looking at a patent that discusses being able to interface with the somasensory neurons in addition to the sweat glands to do things like induce physiologic states and emotional states, which relates to this. And this is just one company. It's just Huawei. There are other companies that are looking into this. I mean, this isn't Huawei exclusive, but they are the enemy of the American people at this point. So big middle finger to you, Huawei. So receptors convey this information to the spinal cord and the brain. We're talking about these skin receptors by converting mechanical, thermal, chemical energy into electric signals. Thus, the skin contains many neurally connected and interacting structures. Okay. So we are going to spend time on nerve stimulation. And what do I mean by that? There are patents. Heinrich Lewis, we're going to do a whole show on Heinrich Lewis. Nervous system manipulation from electromagnetic fields and monitors. Electric field manipulation of the nervous system. Magnetic manipulation of the nervous system. Electric fringe field generator manipulation for the nervous system. Different apparatuses for manipulating the nervous system. Subliminal acoustic manipulation of the nervous system. Pulsative manipulation of the nervous system, which deals with heat. And the other one is dealing with the cooling of the nervous system. Nervous system excitation device. We were going to do a whole show on this. And what this talks about, this guy is using the right frequency of application of things like heat and cool and electric fields and magnetic fields to modulate and change the effects of the brain to cause relaxation, sleepiness, ptosis of the eyelids, a tonic smile, a knot in the stomach, sexual excitement, depending upon the precise frequency used. And he's only using the range of like 2.4 hertz, which is nothing. That's only one piece. This is just an exemplary example. It says the invention can be used by the general public for inducing relaxation, sleep, sexual excitement, and clinically for the control and perhaps treatment of tremors, seizures, autonomic system disorders such as panic attacks. This one talks about using a pulsed fan to impart subliminal cooling pulses. And the reason I share this with you is because when we were looking at the skin and all of those receptors in the skin, that's really what they're tying into. They're tying into the temperature thermal receptors. They're tying into the pain receptors. They're tying into the mechanoreceptors, and they're tying into the electric properties of these things in order to communicate with the nervous system and the brain. And ultimately, what I'm postulating to you is not only emotion, but all five senses based on what is manipulated using electromagnetic energy can basically be recreated into the brain in order to transmit these five senses over the internet and into your body and your brain. We're not done. So they talk about senducers and uniducers and all this stuff, right? In order to convey and transmit the information to a remote location, the senducers, which just transfer the senses into an information domain and then back into a sense. It talks about being provided within the human bond sensorium, and it's a common node that receives sampled information. So they're just doing sampling like they do anything else and then transmitting it over the internet. Let's move on just a tad. It talks about human bond communication, right? Provides users with realistic and complete sensory experience. Effective human bond communication based smart communications shall rely on very high performance communication systems, particularly in order to recreate the reality of the sensorial experience, all five senses. And observing devices should be characterized by the incisiveness and extensity. As described in 2, the incisiveness is the capability of a sense organ to detect and identify the small variations and the strength of a physical property. For example, to describe which of 2 roses is redder, which one of 2 roses is redder than another. Right? That's the incisiveness, one way to evaluate how something is. Conversely, the extensity is the property of an organ to sense the large range of the physical trait. For example, the human eye is able to perceive the colors of a very wide palette. So not only does this system need to have a broad range of sensing, but once it's sensing something, it needs to understand the subtle nuances and the subtle variations. Does your mom make cookies the same way my mom makes cookies? And if not, in order to provide the best sensorial experience, when I smell and taste the essence of chocolate chip cookies, they should be like my mom makes them, not like your mom makes them. And that's the general idea behind what they're trying to quantify here. Do you smell the same as somebody else? Do you feel the same as somebody else? Do you love the same as somebody else? How do you make those unique distinctions and then quantify it, digitize it, and send it to somebody else so that it is injected into their nervous system and their brain, and they have a virtual experience as if it's you and not some stranger? So they need to have very high data rates in order to make this happen. And it says here, the underlying communication network must be stable and capillary. In the following, the future wireless communication systems will be analyzed in terms of their capabilities to satisfy these requirements. Technologies which are supposed to cooperate in the definition of human bond communication systems are presented and described, aiming to identify their distinctive features, which can afford their effectiveness and widespreading, particularly the 5G wireless systems. The localization techniques and the wireless body area networks are considered as the technological components of the human bond communication that will permit to realize global applications and seamless services. Next generation wireless systems, which is identified as 5th generation or 5G, will be the ubiquitous ultra broadband network enabling the future internet. As described, it will enable full immersive 3D experience enriched by context information and anything or everything as a service, XaaS, everything as a service, and will open the way to a world where the network has been reduced to a ubiquitous pipe of bits. And that is why you have these organizations that are creating universal end nodes, universal antennas and universal phones and universal devices like watches and headphones and nanotechnology, which if we have time, we'll get into a little bit, in order to bring online architecture that allows for anything or everything as a service. The only way to do that is to make the internet ubiquitous, to homogenize the internet. And that's the real rub with Huawei or any other telecom provider for that matter. Whoever has control over the universal internet is going to be able to dictate what's allowable to transmit over the internet when we are looking at everything available as a service, including something like intimacy online, or virtual reality training from an expert online. Can you imagine getting football lessons from a pro, golf lessons from a pro, where they literally log into your brain and feel what you feel while you're swinging a club or throwing the ball or running a play? and then providing you constructive feedback. Or you're tapping into their skill sets so that while you're performing those functions, we'll use sports as an analogy, your performance is enhanced because you're actually tying into their brain power and their expertise remotely over the internet in real time so that your body develops the mechanics, the muscle memory with the brain circuitry, the brain power of a professional. It brings a whole new meaning to what the future e-commerce marketplace is going to look like. After the adoption of 5G systems, a revolution in the information and communication technologies field can be envisaged. In the framework of the human bond communication system, the traditional communication services such as voice and video telephony will be enriched by the specific information the sendusers transmit. From the functional point of view, the solution will end up to redefine the network infrastructure as an extracorporeal nervous system. They're talking about the internet, the network infrastructure, the hardware of the internet being an extracorporeal, outside of the body nervous system that ties humans into it, that blends biological nervous systems with the internet, the extracorporeal nervous system that will be the future internet via 5G. In order to allow this visionary functionalities, the future human bond communication systems must cope properly with the extensity and the incisiveness requirements, right? Your mom's cookies versus my mom's cookies. What does that feel like, taste like, smell like? Right? Not everybody likes Toll House. Not everybody wants Oreos. It's worth underlining that with respect to the current wireless communications, the future 5G communications shall guarantee the key performance indicator gains that are reported in Table 1. In this context, the issues of connection, security, mobility, and routing management will be effectively afforded, fully compatible with the current and future incremental 4G releases. 4G, they're talking about, will be guaranteed by the possibility of instantiating any type of virtual architecture and installing any kind of network and service application efficiently. So this works on 4G, just not as good and not as many people. 5G throughput, 1,000 times more in the aggregate and 10 times more at the link level. Latency less than 1 millisecond for remote robot controlled or tactile internet applications. Less than 5 milliseconds for the download of 2 to 8K videos. Notice the only thing that's being advertised to people when they sell 5G is super fast video speeds. Yeah. Super fast internet. Yeah. Well, the priority is going to be for telerobotics, telemedicine, and things like virtual tactile sensations for virtual reality. Only you're the robot, folks. They're just not telling you that part. Spectrum, all spectra, from cellular bands to visible light. And this is a distinction that needs to be made between Huawei and, let's say, United States or European-based 5G. Huawei is selling 5G at half the price, basically, because they're building an architecture that makes the 4G, 3G, 2G systems compatible with 5G. And for that reason, they're selling it cheaper. And that's why countries are buying in. It's a lie, because you need the bandwidth of 5G, what they're selling 5G as, in order to get these types of services. But what it's doing is it's allowing China to be able to install their hardware into the internet infrastructure of other countries. And here's the rub. If we have partnerships, the United States or Europe or any other country have partnerships with other countries, and our networks touch, now you potentially have the ability for China to access another country's network they're not even installed within, because the network architectures touch. And when we start looking at quantum communications, the ball of wax, so to speak, gets a whole lot messier, because now you have a more difficult time trying to intercept and understand signals intelligence. So they talk about accurate localization, right? What that means is they need to be able to track you down to inches. You move left or right by inches, it matters, because if they're trying to communicate with your brain or your nervous system, they need to be able to resonate it. And if you move, they have to change the beam so that the resonance still is working properly. Because if you move while you're being resonated with electromagnetic energy, then the resonance will be off. So it has to be able to track you in real time down to inches or millimeters, which is why the radar technology patents from Google are so useful to look at, because that's what they do. They track millimeter movements. Now just expand that out to the 5G network, where they're able to, they can tell when you move your head left or right. When you lean your ear to your shoulder, that matters if they're putting 2 or 3 different beams in your brain to give you some virtual reality experience, because those waves interact and interfere with each other, and they need to in order to create the right resonance characteristics to do things like give you an active hallucination in your visual cortex and make you smell something that's associated with the image that's being transmitted into your brain, and potentially give you audio at the same time, all through resonance using electromagnetic waves. Human bond communication with 5G, folks. Kind of makes sense now why the regulations are what they are, why you can't fight it, why they're forcing it without trials. And this is just the entertainment experience. And I use that term sarcastically, entertainment experience. This has nothing to do with the health implications and or the potential medical benefits that are going to be resultant from installing these networks. This is just the communication piece as it relates to transforming the ways that humans communicate with each other. They talk about the use of ultra-wideband technology that could be a good candidate for accurate location of smart devices and sensors on and in the body, Ultra-wideband can be used to successfully enhance the accuracy of other positioning technologies. So, body area networks. Nowadays, the digitalization of human perceptions and sensations, so that is, it's a very, this guy, his English is not his primary language, so it's written as English as a secondary language. So it reads out loud funny. Basically what he's saying is that the digitization of human perceptions is a new concept, right? And it's personal information, and it's the frontier of internet communication technologies. He says here, imagine the future, every human being carrying one or more sensors that sense or reveal a very, very personal information. When this information is created by the body, such as tasting a delicious food, touching a new irregular surface, looking at a preferred color, or watching something horrible, it could be only an infinitesimal part of the perception and sensation that the body generates in our everyday life. So what they're talking about is being able to capture everything that's going on in the body that quantifies what it is to be human and what it is to experience something. Now, what does that look like? In order to digitize this information, a wearable device is required. The device will be capable of revealing information, transforming it into digital content, and sending it through communications channels. Thus, the concept is that humans have to carry so-called body area networks, which are devices that function at the body area level, which detect and then transmit the information. Due to mobility issues, this information is usually sent wirelessly. So we're talking about wearables and we're talking about nanotechnology. We'll get into that in a minute. The wireless body area network has emerged as a new technology for e-healthcare, right? Virtual healthcare that allows data of a patient's vital parameters and movements to be collected by small wearables or implantable sensors and communicated using wireless links. Wireless body area network technology has great potential in improving healthcare quality and thus has found a wide range of applications for ubiquitous health monitoring and computer-assisted rehabilitation to emergency medical response systems. And so this is the industry that they're tapping into to ultimately create the interface with your nervous system and your brain. Health monitoring. Now, what do we know of that monitors our health? The benefits of a wireless body area network are many, but mainly this one. Instead of being measured face-to-face, patients' health-related parameters can be monitored remotely, continuously and in real time, and then processed and transferred to medical databases. The medical information can then be shared and accessed by various authorized users, such as healthcare staff, caregivers, researchers, government agencies, and insurance companies. Since the person-related data stored in a wireless body area network plays a critical role in medical diagnosis and treatment, it is essential to ensure the security of the data. Failure to obtain authentic and correct medical data will possibly prevent a patient from being treated effectively or even lead to wrong treatments. Therefore, it's extremely important to protect patient-related data against malicious modification. At the same time, to ensure the reliability and dependability of the data. Protection issues range from the data stored inside the in or on body device to the transmission of the data to the off-body network. To design data security and privacy mechanisms for wireless body area networks means to find balance between security, efficiency, and usability. Robust, lightweight, low latency, and dependable, unbreakable, but simple. In the human bond communication vision, the data are not health related, but still have the same importance since they represent the senses and sensations of an individual. This kind of data can lead to superior profile of the subject, much more than today's algorithms exploiting the Internet of life of an individual. Such superior profiles are pure gold for companies that today spend millions of dollars to buy customer profiles from big digital industries such as Google, Facebook, etc. Folks, are you listening? Do you remember that Google bought Fitbit recently for $2.4 billion? You know that Facebook bought Control Labs that basically is building their own watch that deals with neural interface, being able to talk to the brain and read the brain by measuring the muscle activity. Apple has their watch. And you have headphones by Bose, Apple, and everybody else that have sensors on them. These are the wearable devices that create the wireless body area network for health sensing and other interactivities that are going to be used, and they say in this document, they will be used for these technologies, transmitting your sensations and senses over the internet and or receiving them. Implants or on-the-body devices. Wireless body area network coordinator or hub can be a smartwatch and or a phone. Off to the network it goes, into the cloud. Security requirements, we're not going to deal with that. Obviously, we know the internet's compromised, so it's just a bunch of BS. Talks about smarter radio systems, cognitive radio approach. That's that AI radio stuff we were looking at earlier on in the show, for those of you that are still watching. Possible solutions. Trying to imagine solutions can be added to a communication system in order to support human bond communication services securely. It's a very hard task. Basically, the future human bond communication system will require to add two main features to a classical network security solutions: biometric encryption and physical layer security. Biometric encryption, the science of establishing the identity of an individual based on physical, chemical, or behavioral attributes of the person. Mainly, the concept is the user is not authenticated or identified by something that he or she knows, like a password, or carries, like a SIM card or a chip or a key, but by some biological attribute, which is unique for each individual. The sensation transductor can give an added value to biometrics. Not only biological attributes are unique in human beings, such as a retina, fingerprint, or DNA, but so are sensations, or in particular, answers to stimuli. Human bond communication systems can let the biometric become sensometrics. Answers to a particular stimulus can be used to identify and authenticate a user. For example, the system can send the user a known food taste and then evaluate the sensation answer. That's kind of creepy. Sensations of the user can also be used to encrypt the personal data of the user during the journey on the net. Sensations can be translated into a private key which encrypts the data. Only the individual that can reproduce that sensation of the answer to specific stimulus can decrypt the data and read it. So they talk about cryptography, and this is where I think the quantum internet is going to come into play, but that's outside of the scope. Let me see if I can find. Nope, it's not in here. All right. So let's move to the next document here. We know that all of these nerves are associated with being able to send or receive these sensations into and out of the body. We know that the skin is an access point to the nervous system. I want to show you something. It says here, figure 2 shows a subject described by our healthy brain by sensing it through 5 healthy sense organs, 2 of them detecting wave properties, that's just sight and sound, and the others are sampling materials. So what we're going to talk about now is how do you get the taste, touch, and smell into the nervous system? We get the sight and the sound just by watching your phone or your TV, right? Speakers in the monitor. It's emitting light, it's emitting audio waves. You get those now. How do you get the others? Taste, touch, and smell. So it talks here, to understand the subject, the human bond communication system must work on the way our sensory system works. We have 5 sense organs. Each of these organs are composed of sensory neuron receptors that convert the observed property into neuronal pulses that nestles the information. The neuronal electrical signals travel from sensory receptors to the central nervous system through sensory neurons that eventually reach the brain through the motor neurons. So what they're saying here is that everything travels through the nervous system, through the central nervous system, ultimately through the motor neurons. They can read, receive, and write this information into the nervous system through these various mechanisms. So we looked at the electromagnetic variations already. Now we're going to look at the on-skin applications, things like Control Lab, things like the wireless headphones, things like the Apple smartwatch or the Fitbit or the Samsung Galaxy, and or the nanotechnology from guys like Charles Lieber. We're going to look at that. We have roughly a half an hour left. The brain must receive neurotic pulses from the organs. The property of the subject is received by neuron receptors, either in the form of waves or by reacting with the molecules of the subject that creates the neurotic pulses. So ultimately, it converts to electrical impulses that travel through your nervous system, that go to your brain, and your brain interprets them as something. And those are the unique signatures that I'm talking about are being cataloged and that can be retransmitted into the nervous system to provide artificial or virtual reality. So what does this look like? Here's an example. This place, an island, vacation, got coconut suntan lotion and a Mai Tai or whatever, right? You're going to sit on your couch and have this experience. Well, you can see and hear just fine with what you have already. Do you see what's on this dude right here? You see this thing that looks like a watch? And what this is it's a human sensory explicator, and it's able to induce or extract olfactory, smell, taste, and touch interpretations. Now, you say to yourself, well, no way is that possible. And I say to you, yes, it is. And here's why. When we look at technology, for example, like a watch, we have something like this, a dual EEG no contact monitor from Freer Logic that does this. It transmits thoughts over the internet. A watch with sensors on it and a electromagnetic coil or an antenna that's able to extract and inject thoughts from one person to another. And this is a viable technology from a viable company, and the company is Freer Logic, and they do neurotechnology. They worked for NASA, now they work for the Silicon Valley. Look at neurotechnology, reading the brain, talking to the brain, using neurotechnology. let's look at their hardware. Let's see if we can see the watch. Here's a NeuroMonitor headrest. This stuff's going to be in your car for alertness, drowsiness, fatigue. This stuff is coming out as safety features in your car. We'll look at some Israeli-based companies that are offering these solutions with their radar. Here's something that you wear on your arm that interacts with your brain. It's a neurocognitive system for ADHD. It helps train the brain to stay focused. And there is a watch here somewhere, if I can find it. I'm not sure. There's the body wave. No, all they've got here on this website is the car seat and the armband. But they have a watch. You saw it here in the headset. Excuse me, up here, right here. Body-based neuromodulator. It looks like a smart band for like a Fitbit or a watch. And they actually have one of these. You can search. Let's try. FruitLogic watch. Let's see if we can find it. I don't want to spend too much time digging on this. I have it saved in another location, but yeah, it's not popping up. It literally looks just like a smartwatch. It's the same profile. It's the same everything. So I will look for that and share it with you soon. But anyway, back to the patent that actually discusses how it works. It literally talks about injecting neural code. So a neural message, digital signal processor to encode digitized information as a neural message that is injected into a person's peripheral nervous system. For example, methods of magnetically, right? Transcranial magnetic stimulation of the visual areas of the occipital cortex, indirectly modulating neural activity through rapidly changing magnetic fields, or electrically an array of sensors on or under the skin, or haptically stimulating the nerves that induce neural activity that can interpret signals such as hello. It can be used in combination as a neural stimulation method to exchange information between brains directly as neural code. So if they can stimulate the visual centers of the brain to allow for synthetic telepathy, they can also access the other parts of the brain. Yeah, I'm postulating to you that smartwatches can do this. It's all in the software. It's the electrodes. It's the electrodes that make this thing and the antennas. And if your smartwatches have this stuff, your smartwatches have the electrodes and the antennas in them. That's what makes them work. That's what allows them to sense your health. External sensor arrays, wireless transmitter units. That's so it Bluetooths and talks to the cell. Apple Watches talk directly to the cell network, and they talk to your phone. And these sensors here, these are just electrodes that touch your skin, and they inject code into your nervous system through the electrical contact of your skin. So this is the watch. And here's the headphones. EEG monitor with capacitive electrodes and a method of monitoring brain waves. And I have not posted the pictures here yet, so bear with me. I'll bring this up right now to show you. So here is a picture, and what it talks about is having electrodes, right? There's electrodes on these earphones, and there's electronics inside to play sound and electrodes on the outside to measure your brain waves, to do things like understand your thoughts and or understand if you're sick, if epilepsy or Alzheimer's or something like that. That's how these things are, that's what they're made for, but they do so much more. And here's the real rub, folks, is they talk about having capacitive electrodes. Capacitive coupling to an ear canal of a user comprises at least 2 capacitive electrodes for recording a signal. So an ear insert for positioning within the human ear. And it says for at least 1 electrode being placed at the ear insert. In the present context, the electrode is meant to encompass a capacitive electrode, an electrode that does not require galvanic contact, actual skin contact, nor electrical current running between the electrode and the skin. It just emits an electric field. Capacitive electrodes may be implemented in the ear for picking up EEG, your brain waves, for picking up your brain waves through capacitive coupling to the ear. So we have capacitive sensors in headphones that are able to read your brain, that emit electric fields. Then when we look at nervous system manipulation, particularly nervous system manipulation of electric fields, you will see that the very same capacitive fields can induce changes in your brain, which is exactly what the watch patent talked about, right? Were these electrodes and or the antennas being able to do things like transmit thought into your brain. And so it gets better, because here we have the oh so familiar Apple AirPods. And what you will see here is that these also have capacitive sensors. The AirPods, these Apple AirPods, have capacitive sensors. And this is what they look like. They are literally sprayed on, or they are underneath the outer housing, and they emit electric fields, and they are all over the AirPod. That's how you can play, pause, turn up and turn down the volume by touching your headphone without having to touch your phone. You can use the AirPod to control music and volume and all of that. Well, these things emit electric fields. So there's your AirPod. Now let's get into the Beats by Dre. Okay, these are the Beats Tour by Dre. Apple bought Beats by Dre. Here's the patents, the patent for this version, the Tour or the Tour 2. And what I want to show you here is that in this patent, it literally talks about electric fields. These are the capacitive electrodes that generate electric fields between the two of them that can be controlled. They can actually turn them on or off on demand and create larger electric fields or smaller electric fields. They can turn up and turn down the voltage. And these are integrated in these headphones so that it understands the orientation of the earphone in your ear. That's what it's patented for. Let's move on. More earphones with sensors. These are the sports version of Beats by Dre. And these talk about having electrodes literally in the over the ear. And we'll go into why this is so important when we have more time on our show, when we start looking at nerve stimulation with devices that look remarkably similar and or make contact with the same locations that these do as you wear them on your ear. These are electrodes. These dashed lines are electrodes. So you have the strength member that have electrodes here that literally talk to the circuitry in the headphone. Beats, Apple. And here's the oh so familiar studio Beats that are so popular. Look at that. These are all electrodes that are in the earphone, the headphone. They go over your entire ear. They can play these things like Simon Says, or make them flicker like Christmas lights. And they can generate the same type of electric fields we saw in the last, or the patent before. Electrodes everywhere on these things. And these are right by your head, folks. So we've got a watch, and we've got headphones that potentially interface with your nervous system, your skin, and the nerves in your ear. let's see, nerve in ear. And I'll show you real quick what it is that I'm talking about. So you've got, there's one particular picture that's actually a decent one. I'll show this one to you real quick. Nerves in the neck, here's your ear. There's all this stuff going on that ties into your brain. All that's, but there is a better diagram, if I can find it. Here is the anatomy of your ear, and all of these things have associated acupressure points. These are vagus nerve stimulating components. They're actual medical devices that stimulate your ear to modulate your nervous system. Here's one. Here's your ear, your occipital nerve right here. Excuse me, number 2, your occipital nerve. Your auricular temporal nerve up here. You have the auricular branch of the vagus nerve right here, which is where all the earbuds, they plug into. And you've got your great auricular nerve here. So there's all kinds of ways to access the nervous system, and therefore by extension the brain, by putting these electrodes that generate capacitive fields and or electromagnetic waves right next to your head. That all kind of ties into this whole human bond communication thing, being able to create these artificial sensations. And when these systems come online, the architecture and hardware, or the hardware as it relates to the user, it already exists. All they're going to have to do is be able to modulate something like your ear or the nerves in your skin around your wrist, and you're going to be able to get this stuff. The question is it already subtly happening right now? So we're going to spend another show on human bond communication. And the reason we spent so much time on it, and we're going to spend more time on it, is the future of the internet. And this is the real battle space when you start looking at Huawei and you start looking at other telecommunications companies. The future of the internet is with humans on it. And with humans being looked at as nodes on the internet, being able to have software upgrades like your phone, being able to be remotely managed like your phone. And the consumer application, so that everybody buys in, is the extremely intense virtual reality experiences that will be enabled with these types of technologies by being able to transmit sensation. Can you imagine having your ear nibbled on, or somebody caressing the back of your neck? What does that feel like in virtual reality? Let's look at the nanotech before we run out of time. So, Charles Lieber, this is a document that he wrote, Charles Lieber, Semiconductor Nanowires, a platform for nanoscience and nanotechnology. And what I want to show you here, nanowire, nanoelectronics, biology interface. A second example of the potential of nanowires. I will review work focused on the interface between nanoelectronics and biology. Why is it important to merge nanoelectronics with biology? The answer to this question is readily apparent when one recognizes that the natural scale of communication in biological systems is the nanoscale. For example, using nanometer scale ion channels of electrogenic cells and the nanometer scale macromolecules involved in signal transduction. Therefore, to build a seamless integrated interface between electronics and living biological systems, it is necessary to work at the same level as the biology, which is the nanoscale. If we were able to achieve this goal, we can open up numerous opportunities for the creation of powerful new tools for conducting fundamental and applied studies to realization of completely new hybrid materials. Work on the nanoelectronic biology interface began with studies in the early 2000s. which were designed to exploit the high surface to volume ratio of emerging nanoelectronic field effect transistors as biosensors. Notably, these seminal studies demonstrated that functionalized silicon nanowire field effect transistors could serve as exquisitely sensitive detectors for recording changes in solution pH and measuring the binding of proteins with high sensitivity and specificity. This work was subsequently extended in a significant manner, for example, by studies demonstrating multiplexed real-time detection of cancer markers in proteins, including detection of 100 billion-fold excess proteins in detection of DNA and DNA mismatches relevant to disease, drug screening and discovery, detection of virus particles. In addition, there remain interesting scientific questions to address, including what are the limits of detection? Can nanoelectronic sensors function under physiological conditions of high ionic strength? We've begun to address the first fundamental questions in two ways. We've investigated the detection of single particles in virus sensing studies. They showed unambiguously that it's possible to detect single viral particles. Now, why am I reading this to you? I'm reading this to you in order to illustrate the sensitivity of nanoelectronics as it relates to cellular level measurements and cellular level stimulation, down to and including understanding changes and variations in DNA, and having all of this be readily available over the internet, and why Huawei is such a freaking problem. I believe that one of the greatest opportunities lies in the more complex interface between nanoelectronic devices and cells and tissue. Motivation for this area are apparent when one examines, for example, the brain and the way in which it's wired. The cells in the brain, neurons, are interconnected by nanoscale synapses, not micron, and larger scale structures used in the past for building electronic interfaces. Hence, to communicate with the network of neurons at the natural scale in which they communicate, we need nanoscale electronic devices. This dude's talking about integrating nanoelectronic devices into brain cells. Oh, by the way, Harvard, Charles Lieber, Air Force Research Laboratory, cyborg cell, molecular nanoscale circuits for active control of cells. This dude is putting nanoelectronics inside of brain cells. The goal of this work is to develop molecular nanoscale circuits that control cells via external radiation. That's electromagnetics, folks. External radiation. Could also be sound based on the way the nanotech is made. We develop silicon nanowire probes as platform elements of these circuits and demonstrate their insertion into single cells, followed by stimulation to elicit cell signaling, which means they're actually talking to the cells, finally achieving a scalable modular nano device platform capable of recording high amplitude intracellular electrical signals in electrogenic cells. In parallel, we developed a conformal deposition technique and site-selective deposition of polymers to modify probes, and an approach to decorate nanowires with heavy metal-free quantum dot emitters that provide strong, macroscopically addressable and reproducible nanoprobe emission signals. So what does that look like? Nanoscale communications, MIT, and the University of Toronto in Canada. Nanoscale chips, nanosensors, nanomemory, nanoantennas, nanotransceivers, nanoprocessors, and a nano power unit, all at the nanoscale. And what I want to show you is when they talk about in-body sensors with this human bond communication, it's literally wiring up your brain and your organs and your nervous system and having that wireless body area network, something like a smartwatch or headphones or a mobile device or your Wi-Fi router, talking to the nanotech in your body, reading and writing to the cells in your body. And you say to yourself, how is that possible? Here's another more colorful example. Interconnected body area networks. This is from Georgia Tech, another DARPA school favorite. Monitoring things, correcting things like Alzheimer's, epilepsy, depression, glucose monitoring, talks about nanomachines, heart monitoring, cancer monitoring network. I'll go back because I want to show you this. talks about cyborg cells here. And what I want to show you, these are the little nanotech wires. These are the nanotech wires, and they can make them as transistors. And this is what they look like at the nanoscale. This is Charles Lieber stuff. And what I want to show you is this. Where is it? This is them putting a transistor inside of a cell, in and out, and it transplants just fine, and the cell doesn't die. So they've proven that that's possible, and they can stimulate it and or read what's going on in the cell. Here's a color graphic of how they do it. They dope it with ligands that are similar in composition to the cell wall, so that the cell wall understands it and thinks that it's supposed to be there, and it just becomes something interpreted by the cell wall as an ion channel. They can do this at the nanoscale, where they're fusing biology and nanotechnology together. But this right here, this is cyborg cardiac tissue. And what this is, these are nanowires inside of heart cells, where they literally are able to control the beating of a heart or heart cells using radio waves. So before we get there, I want to show you the rest of this. This is the Internet of Nano Things. Everything's connected. Everything is connected, even you. And it all talks to these little nano nodes or your cell phone. And we're talking about integrating things like lights and power lines and everything else into the Internet of Things in the smart cities. Yes, age of accountability. They need their own IP address. Let's just go there right now, shall we? So what I'm going to show you now is a patent from AT&T. And it talks about being able to network the human body, routing policies for biologic hosts. So here's the patent. I'll show it to you for posterity. Naturally. Okay. Nope, this is the wrong patent. Stand by. Routing policies for biologic hosts. This other one, this is the one that talks about cyborg cells, what we just looked at. So it says here, in order to transmit or receive electronic signals from the nerve cells, nanoscale wires, in such a fashion, electrically unitary structures may be generated. For example, cyborg tissue can be created whose biological functioning depends not only on the cells or the tissues, but on the electrical components as well, such that the distinction between the biological and the electronic systems become blurred. And in this same patent, it also discusses radio transmitters. The conductive pathways can form an electrical circuit internally contained within the cell scaffold and or that extends externally of the cell scaffold, such that the electrical circuits and the electrical communication with an electrical system, such as a computer or a transmitter, for instance, a radio transmitter or a wireless transmitter or an internet connection, any suitable pathway, conductive pathway may be used. They're talking about using these nanotechs, being able to resonate them using what they call on-off keying, which is a very simple modulation technique to communicate with radio transmitters, something like that would be from your cell phone, your smartwatch, or 5G. Now, how do they do that? They do things like this. This is a patent from AT&T that discusses routing policies for biological hosts, AT&T 2012 and 2015, AT&T intellectual property. And what this patent gets into, right, is the physical realization, hardware implementation of neural networks, neurons or parts of neurons using biological neurons connected to an integrated circuit. The communications device may receive neurological signals from a neurological area network, for example, the woman's brain. The communications device may then forward or route these neurological signals to an external communications network. The woman's neurological signals may thus be transmitted and sent into cellular data networks or Wi-Fi networks, routing to some distant destination for analysis. The woman's communication device may also receive the external communications network that are destined for her neurological network. The concepts described herein may be applied to any wireless or wireline communications network, regardless of the physical componentry, physical configuration, or communication standard, which means they can talk to you through anything, including power lines. Each biological signal may be received from or identified with a different biological region within the body area network. Some biological signals may originate from or be identified with an arm, while others are identified with a leg. Granularity may even be finer, thus identifying biological signals from a hand, a finger, a toe, or even a single cell. And it goes on. Each different biological region may thus be addressable to send and receive communications to and from the communications network. When the communications device receives a biological signal, the biological signal may again be identified by its particular biologic region within the body area network, subnetting your body. Once the biological region is known, the interface application consults a routing table, just like they do in current communication networks, for the corresponding biological address assigned to the biological region. Exemplary embodiments may include biological subnets. The above paragraph explaining communications may be destined for a particular neurological region within the brain and or to a particular biological region within the body. And they talk about using IPv6, where the subnet bit spec indicates that a predetermined number of bits for the IPv6 spec may be reserved for biological subnets. Each neurological region within the brain and or each biological region within the body may thus be addressable using a particular subnet. So just as the communication device may have its own unique IP address, each neurological region within the brain or each biological region within the body may have its own unique IP address. In this way, signals and communications may be addressably routed to different destinations within the brain and the body. One person's body area network may communicate with a different person's body area network. Indeed, one person's neurologic area network may communicate with a different person's body area network. As one person's intrahost networks are addressable, different people and animals may conduct intrahost communications. In more simple terms, one person's brain may control another person's body and vice versa. And this is the risk of Huawei and the overarching concern I have with things like 5G. And with that, I'll stop.
Hello. How goes it?
Hi. It's going good. How are you?
I'm doing well. That's a lot to process, and I'm gonna have to go back. I know for myself, good. I'm just gonna have to go back and take a second look or a second listen, which I encourage everybody to do, because I know nobody can process all of that information at one time. But that's why you have to go back and look at it again, and you'll have it on your YouTube channel, correct?
Yeah.
Yeah. I mean, you really can't, like, every single thing that you said, but that's why you have to go back. So, but it's really, really great information, and we need to know these things, because they're doing this crap like right in front of our faces, and if we're not wise up to it, then they're gonna overtake us. Was that the gist of it, or what?
Yeah, that's pretty much the gist. I don't want to